Hi, my name is Jonathan Dodge. I'm a Senior Applications Engineer at United Silicon Carbide, one of the developers of FET-Jet Calculator. In this video, I will just walk through some of the topologies that are supported and show a little more in detail how to use FET-Jet Calculator. So the applications are grouped into three groups. We have AC to DC, DC to DC, which is non-isolated DC to DC converters. So you have buck boost, 3-level boost, and then half bridge buck, half bridge boost. And then we have DC to DC isolated, we have phase shift full bridge, we have LLC half bridge, LLC full bridge, and the dual active bridge for bidirectional power with isolation. So going back to the AC to DC, I skipped over that. So we have conventional power factor corrector, totem pole PFC, modified Vienna rectifier, and 2-level voltage source inverter. So within any topology, we have a circuit diagram to help you to know what we're dealing with. Parts that are involved in the calculations are highlighted in black. You can select a part number by clicking on it. It brings up a part selection table. The fields are sortable, and then you can also select just individual parameters if you want to ignore all the others. And if you click on a part number itself, it's a hyperlink that takes you to the product page for that part, and you can download datasheets and SPICE models and order parts online. If you change part numbers, let me get myself out of the way here, it immediately updates the calculations, so you can see over here on the right the changes. So that's convenient if you want to see the result of different part numbers, and when you're done you just click on the X. There are calculated parameters for each topology, and useful to know about. In this case, we're dealing with an AC to DC circuit, so we know the RMS current and peak current per FET and diode, modulation factor, and temperature corrected RDS on. We have the losses per FET split out into conduction, switching, turn on, turn off, and the total loss, and then also an estimate of the junction temperature. So that's per FET, and then in this case there's a diode, so we do the same thing there. Negligible switching loss, we just have conduction loss in this case. So then we add up the total losses per leg. You can have any number of legs. Those are basically self-paralleled legs. Let's show you that. Let's say we have three legs. So now it's the same as paralleling 3 of these converters. So our losses go down, of course, and then you can see the resulting efficiency, but it adds up the losses for all 3 legs for you. So that's just a real quick little further details about how to use the calculator, and certainly appreciate any feedback that you have, and I hope that you enjoy using the calculator and that it's useful for you. Thanks for watching.